Great. Thank you guys for joining us today for our webinar, Fact or Fiction, Separating the Hype from Reality in Manufacturing Intelligence. My name is Jackie Slatt, and I want to thank our presenters, Pradeep Paul and Vivek Puthawais, and everyone who helped put this webinar together. I'm going to be the moderator for today's webinar, and we're going to go through a quick overview of eTech Group, give a short introduction to both Pradeep and Vivek, and then we will kind of get into the meat of the presentation and leave a little bit of room at the end for any questions. So thank you again, and let's go ahead and get started. eTech Group is one of the top 5 system integrators in the United States. We have locations across North America with over 600 resources and 450 engineers. We work in a variety of industries and have expertise ranging from process automation to advanced software and more. We are driven and grounded by our purpose, which is to free people to achieve the full potential of human creativity and innovation. Our clients are doing amazing things, and we guide and enable them to advance their missions using the next generation of technology and human interaction. eTech Group is a technology agnostic partner for our clients. We have the experience and expertise that allow us to make an impact from the top floor and to the shop floor. We vet our technology partners across the all layers of the technology stack to ensure our clients have the best solutions in the industry to draw upon. So that's just a very quick high-level overview of who eTech Group is. And then I want to do a quick introduction to both Pradeep and Vivek. So Pradeep is a technical lead with over 20 years of experience in the automation and controls. He holds a master's degree in chemical engineering and an MBA in business analytics. At eTech Group, he focuses on architecting OT solutions that help customers drive their manufacturing intelligence initiatives. And Vivek is the Director of Sales and Marketing. He has over 30 years of experience in manufacturing and automation. And at eTech, he is responsible for the technical and sales development. So now a little bit about this webinar. And any webinar eTech hosts, we like to have a little bit of fun. And so we will have some engagement throughout the presentation. Just please play along and vote as you see the prompts come up on your screen. And with that, we will dive in, and I will hand it over to Vivek.
Thank you, Jackie. Actually, we're going to start off with a poll. And what we're trying to determine here is, are you facing any of these challenges at your sites? First one being, do you have disparate systems and data sources, like islands of automation that lead to data silos? Does that mean you have limited visibility into the overall plant operations? Do you have a challenge providing the right information to the right people at the right time because of these data silos? And then, do you have a lot of data without any real actionable insights? Meaning you have a lot of data, but you really don't know what to do with it. Just wanted to put that poll out there and gauge this group's responses.
Right, looks like we've got some answers, so I'll move on to the next slide.
Yeah, I mean, as our polls indicate, a lot of people have many of these challenges. The fact is that you're not alone. So according to a survey by the Forrester Consulting Group, 97% of manufacturers face hurdles when it comes to collaboration and productivity. In fact, of those, 35%, 35% lack the ability to use the data that they have to make decisions that might keep them competitive. So the point is that you're not alone. And our goal today is to provide some pathways or discuss some pathways in which you could overcome these challenges when it comes to when it comes to data silos and providing information. I'm going to hand it off to Pradeep now and talk about what manufacturing intelligence is. And Pradeep, you want to?
Yeah, we can go to the next slide, Jack. So before I delve into what manufacturing intelligence is, I wanted to recap some of the other technologies available to us. One is artificial intelligence. And so what artificial intelligence is a set of technologies that help systems learn, reason, and act autonomously. So for example, day-to-day use is the self-driving cars of Tesla. They use a lot of machine learning and neural networks, and they can actually get you from one point to another, or just autonomously. And the other thing is ChatGPT, which is using large-scale models and AI and reasons very
popular.
well, very popular. So those kind of things are the common uses, and it's spreading across different industries and different areas of use. But in context of manufacturing, we're not there yet in terms of that autonomous AI use cases. But what we do have is a subset of AI, which is called machine learning. And machine learning models, what they do is they take the data sets that we give, and you apply algorithms to it, models to it, and so it will help you predict or prescribe actions, which it gives you insights on your operations. So most of our use cases in manufacturing intelligence is those kind of use cases of machine learning. The other one which is popular is computer vision, which has been there for a while now. So you can use your vision systems to detect, use ML to train your models to detect faults in products, or you can do classification. For example, if we have a different, like a lot of products coming through the conveyor belt, it can classify which is what, and it knows what which products to redirect to which conveyor belt in real time. So those systems are getting very popular and are used right now. The next thing is I wanted to draw upon the differences between business intelligence and manufacturing intelligence. So business intelligence is using AI and ML for business purposes. For example, if you have all the data about your customers and the sales numbers, you can actually then choose, you can dive a little deeper into that data set and figure out which customer base has the best revenue for you, best profit margins. If you have SaaS-based products, you can see which features are used the most. A lot of marketing tools use AI for messaging purposes, segmentation of their customers. Amazon uses AI and machine learning for the recommendation engine. So once you buy a product, it'll look at all the other people who have bought that same product and recommend this and drive sales. Right? So in general terms, it is using systems and solutions to use the business data for improved business decisions. Right. So if you apply the same technologies to the manufacturing data, essentially that's what manufacturing intelligence is. It's the data sets which are different. So in very broad terms, it is solutions that help engineers turn plant raw data into actionable insights. Right. So we're only focused on the manufacturing side, and we can use all the technologies that we have in terms of AI or ML and turn manufacturing data into insights.
So in other words, business intelligence is more focused on business decisions like revenue and profit, and rather what we're going to talk about, manufacturing intelligence, is focused on plant optimization and improving the plant efficiency of the plant based on the data that's coming out of the plant.
Exactly. So next slide, Jackie. So before we get into the manufacturing intelligence initiatives, right, we do like to take a step back and figure out where we are in our plant. What is our plant capable of? So to understand that, we start looking at the function block, or the fundamental blocks of analytics. There are 4 kinds of analytics that we can do, generally speaking. One is descriptive. That's the what's, like what's happening right now. If you can do that, it's descriptive. The diagnostic is why things are happening. The predictive is when things will happen, and prescriptive is what should I do. So for example, if you look at the plants right now, what you're working on, or as plant operators, if you are able to trend any data set or any process parameter across a particular batch or a production line, if you're able to get the trends, right? High, lows, standard deviations. You're able to get alarms, which is the most common occurring alarm. Even OEE data, the overall equipment effectiveness or efficiencies. So those tells you downtimes and reasons and things like that. But those tell you exactly what the plant is doing right now, right? Beyond that, you don't know. You have to take more. You need to have processes in place to work upon that data.
So the descriptive model is basically if we have enough information to describe the operations.
Right. Trend it. That's descriptive. Now, if you have to go beyond that to get to the next step of diagnostics, you've got to use that data and try to model something out of so that you can understand, you can predict an outcome based on current conditions, right? So that is the diagnostic part of things, which you start with the model first. Our goal is to get you towards the rightmost part, which is prescriptive, right? So what we want to do is in diagnostics, we want to make sure that you have the ability to have data models where you can have data platforms that you're able to model a system. And then once you do that, in predictive, you can actually figure out when things are going either up or down in terms of outputs, and then prescriptive is giving recommendations.
Based on those predictive models, yeah.
So now that we know where our baseline is, how do we get from one spot to the other? If you're in descriptive, how do you get to a diagnostic level?
Yeah.
And that's something that we're going to start talking about the use cases.
Yeah. That's in fact, now that we have a basic understanding of what manufacturing intelligence is and what the analytics that are enabled manufacturing intelligence. We have a quick poll coming up again, Jackie, if we go to the next slide. And this is, we want to know if you think that manufacturing intelligence does not apply to your site, based on the information we just heard from Pradeep. One thing to think about is, think about it from the perspective that manufacturing intelligence turns raw data into actionable insights. So with that in mind, let's do a quick poll of whether you think manufacturing intelligence does not apply to your site. I mean, that's fiction because our polls indicate that many people don't think it applies to their sites. And the reason we think it's fiction is manufacturing intelligence solutions can be implemented in any production facility, regardless of the digital maturity level. Obviously, the more mature you are, the fewer steps you have to take. But the analytics that are enabled by manufacturing intelligence can be derived out of any production. And we're gonna talk about some use cases that we've deployed over the years that talk about how we.
So in this webinar, we'll go through 3 use cases. The first being digital SMEs, which is essentially data platforms which aggregate information and then drive towards giving our operators the right information to the right person at the right time. Right? And then the second use case is energy management. So a lot of companies have sustainable initiatives where they're trying to drive down the cost of energy or consumption, water, big thing, gas, electricity. So all of those, there are use cases where we're deployed where you can gain a good understanding of how much energy you're using per product lines, and you can go more granular with that across your manufacturing sites. And the third is the most powerful use case, which is prescriptive analytics and more process automation. So we'll go through all of that. Before we start into the use cases, I want to get a poll going. So consider this scenario. You are in your manufacturing site and the operator comes for whatever reason unknown to him, the production line is stopped, or the batch is held. And he has only his SCADA system to view or go for information. And he doesn't know where else to go. So the first thing he does is go to the controls engineer, right? So now the controls engineer has to now dig into a lot of different systems. But by then, the QC's got wind of your production is stopped due to whatever reason. So he or she is worried that they cannot release the product because of deviations or quality issues with it. So she needs to be very careful. She needs to know for certainty that there's no quality specs which are violated. On top of that, your supervisor's like, okay, when do I get this system on site? Can I start another line?
Yeah, he wants his product going. Yeah.
Yep. And his question is, if I start this, will I get to the same scenario again? Because I don't know what my cause is, whether it is upstream with utilities, what is the issue, right? So our poll to the audience is, in your current plant or wherever you're working in, how many systems at a very basic level do you need to access to get all this information out and to get to a baseline of why you know that the system is being held?
We'll give everyone a minute to vote on what they think that number is. All right, looks like we're about ready to go. So here we go.
Okay.
So yeah, as we suspected, most of this group here think there's at least 4 systems that need to be accessed, and that's typical. That was our experience as well. The operators have to go to an MES system or the batch system, and perhaps the ERP system.
The PLC to go and look at all your control system, whatever you have at ECS, to go and see what's stopping, why is the batch held,
right?
Some interlocks and things like that. Historian, so at least 4 at the minimum, right? So if you go to the next slide, Jackie. So look at he's exasperated, right? So this is, we're talking about one line, one equipment. And if you're operating many equipments and everything stops at certain times, then it becomes extremely hard to get control of everything, because your resources are held is stretched thin with looking at all the systems in. So why is this the case, right? So traditionally we've used Jackie, if you go to the next slide, yeah. So traditionally what we have used is we've used the S95 model or the Purdue model to deploy RLS solutions, and makes perfect sense because you want to link
well-established model,
right? And it makes sense too, right? You're grouping all like resources to one level. So your level zeros are your sensors, your field equipment. Then you get aggregated up to your PLCs and your SCADA systems. Then you aggregate up to the MES, which is kind of your layer between your business systems and your manufacturing systems. So inherently, when you look at this, it's kind of siloed, right? And when you look at this too, the data sets also are siloed. It's all in its own systems. From an OT infrastructure point of view, it makes complete sense because you can do segmentation of your networks. You can open only the ports you need to allow traffic to go through. You can figure out which system needs to be in the DMZ. But in terms of data accessibility or anything to do with aggregation of information, it becomes extremely hard. Especially when you have all of these personas in your site who needs to access more than one system. Right. So this leads to data silos and being reactive in maintenance rather than proactive, and it's less flexible. So how do we correct the scenario? What have we done for a lot of our customers and to help out with this use case? And Jackie, if you go to the next slide. So what we have done is deployed data platforms, and these data platforms act as digital SMEs. So the data platforms, they can aggregate information from any different sources. So whether it's time series or alarms or anything, spectral charts for now are coming in. Once you have all of this information into a data platform, then you can go and you can deploy machine learning models against your data. You can trend it. So what we have done in the past is we had dashboards for all your process parameters, your CPP, CPI, KPIs, CQPs. You can actually make it granular, so you can go and filter this based on equipment according to line shift. You can do trend comparisons between two runs. You can superimpose all the alarm information onto a trend or a particular run. So you can do root cause analysis with this thing. With these platforms, you can extend the functionality to batch analytics. So if you have all your batch data pushed to the platform, you can compare between cycle times of phases. You can get all the phase parameters, report parameters. So everything is in one place. And the best thing about this, it is a system where anybody who logs in, it knows who's the persona who's logged in, and it'll give you that information.
So the right information to the right
Right
people.
person, exactly. The control engineer does not be the single source of information. Not everybody has to hound the controls guy or the process guy. Anybody can go and log in, and based on his persona and what is visible to him, what he's got accessibility to, then he can get all that information through. And one important thing with this is we've also had job aids. So in the sense that you can annotate any alarm or any equipment. So for example, if you have, say, a batch reactor and it's now taking a long time to get to set point for pH or even temperature, you can annotate this saying, okay, this is what I've seen during my shift. So people who are coming after you can be proactively know that this is a problem. So we've done a lot of these shift handover notes, logs, and work instructions too, SOPs baked into this data platform. So the next use case, Jackie. So this is awesome. So once you have something like this, everybody is happy.
Yeah, he's not being hounded constantly.
All right, now we're ready for the next use case.
So the next use case is in sustainability measures and how do we deploy them? So a lot of companies now are, they have your scores, right? The carbon footprint, lowering that, sustainability, making sure that you're consuming less of resources. So in what we like to say is, if you cannot measure it, you cannot manage it. So this kind of infrastructure it's very granular. So we deploy meters depending on what you're going to measure. So power meters for electricity, water and gas meters for the other utilities. And you deploy it in a way that it's you start with the incoming. So from the providers, you put meters which in like totalizes how much is coming through.
Right.
And then you have systems. So your first line of consumers are utilities. So you put power meters on all of your utilities, so you know how much each unit, like a compressor is using or a chiller is using, and then you go downstream. Right. Beyond that. So you can go to any business area, like a manufacturing line. So you've got that granular information of how much each equipment is using in terms of electricity, gas, or water. So if you go to the next slide, once you have this infrastructure in place, this is in a SaaS-based application provided by our partners from Rockwell called FT Energy Manager. So what you can see here is that these are all pre-configured dashboards. So once you have all those meters and you've loaded all the data from the meters and you've extracted out and put it into the cloud or this platform, within a week or so, you've got these dashboards up and running. Mm-hmm. And what this does is it gives you consumption per resource type, whether if it's gas, whether you want biogas or propane. You have resource type based on electricity or propane, how much it's used. In the center, you see that pie chart. It looks at dollar values. So you can actually have APIs connected to your energy providers directly, and you can get the rates in real time. And then you can compute how much are you using in real time. And if you go down, if you see those stacked bar charts, those are actually telling you if you have a multi-product system or a site, how much energy you're using per product. And if your infrastructure is that granular, you can get to that level of information.
And it comes down to you could plan this having power meters based on suite, and right. Some of our customers are contract manufacturers, CMOs, and the way they use it is to analyze which customer is drawing more energy so they can bill accordingly. And also another use case in this context was line obsolescence. So a customer was able to identify that this particular line is drawing far more energy, and that's because the hardware and the
not optimized.
was an optimizer was obsolete and needed some replacement.
Yeah.
So when we think of obsolescence, we always think it's going to cause an operational loss if it goes down, but really there's a cost associated with how much energy it's also being used.
Yeah, that's a very good point.
Yeah.
So yeah, these initiatives can be easily deployed with, the time to value is very quick here. Once you put the meters in, that's the infrastructure part, and then everything else in terms of analysis is very quick to be for you to get all this information out.
You can go to the next slide, Jackie.
Yeah.
Okay.
So this is my favorite use case, and this is prescriptive analytics, which I think is really cool. So what the use case here, or the problem statement was, there's this company which is making paper, and they bought these OEM machines, paper making machines, and they are concerned about the output quality of the paper. And typically they use three measures. One is moisture content, and then strength. And there are two variables to the strength, but we'll just, for this purposes, we'll just concentrate on one, like tensile strength. And the problem with the system is to get this specifications, right, to find out if the quality is good or not, it's an offline measurement. So you have to, while you're producing paper, you go and take a sample and you test it offline and come back. So just by the use case itself, it's a very lagging indicator, because by the time you take it and you realize that your quality is not up to spec, you're always in a reactive mode, right? So what they have done is they have modeled this whole system out that they can predict the output values based on your inputs.
And for this use case, we partnered with Odin.
With Odin, exactly, yeah. And Odin is really good with process AI and process optimization.
So Odin is one of the partners that focuses on process modeling and process data analytics.
Yeah. So here we got this equipment right off the bat. You can trend at least 20 parameters, but this doesn't mean that all 20 parameters actually contribute to your output being in certain specifications. So what they have done is they've looked at all the 20 parameters and have boiled it down to only of these 5 parameters, which actually affect your output specification or quality. And then they've done a model where they can predict the quality in real time. So you don't need to go and get offline measurements. And if you look at the moisture content, the predicted and the offline, the predicted is like 12.62 and offline 12.75, very, very close
right.
on the top right. Yeah. Very, very close. So now you don't have to wait for your results to actually take action. So once they have done that, once you've got the predicted output, there's so many use cases now, right? What they have done is they've said, okay, now I know that I can predict my output quality based on this model. Can I optimize it? Can I use less raw materials and energy? And that's what they've done. So what they've done is they've minimized they recommend the settings, the best settings which will have the lowest cost of raw materials as well as energy. So if you look at the left, those boxes there, the colored boxes, so there is recommended and there's the current values. And there is a dead band. If your recommended and your current values are within a dead band, it's green. That tells the operator he doesn't have to do anything to it. In the cases where it's red, it's off, and so you have to take some action. And he is, encouraged to use the recommended settings, right? And same thing with yellow. It's off, but not by much. And then if you go down to the end here, to the bottom, you can actually see the predicted. So down below, you can see actually the predicted savings of using the recommended settings. And that's amounts to like $2,000 per hour for this asset. So if you scale this, if you have 5 of these assets or 10 of these assets, that's $20,000 per hour that you're savings on operating costs.
By using these recommended settings.
These recommended settings.
Yeah, that's pretty substantial. So one thing that we've discussed is was the intent of this project to sort of take all the tribal knowledge? Because I would say there were operators who knew that, well, if I have this setting, then this would have
Yeah.
be a best. And was one of the intents to replace that sort of tribal knowledge as an overall scheme, so it could help all operators?
Yeah, that was maybe the byproduct was probably that. So I think what they found was the output is always variability. Like sometimes you'll have some ships will have very good performance,
Yeah.
right? Some other ships will have not much performance, and they wanted to make sure that at any time it's optimum level. And and if you go down and don't know the use cases, but if you go or the reasons why there's this variability in output, but maybe that's the case where some operators might have just joined in and not had that nuance enough for the intuitiveness to know what settings to use. And this levels the playing field, at least
For
in terms
every
of
shift,
for every shift. And this is almost like putting on like an Iron Man suit, is what I've heard. Iron Man suit for our operators.
Nice.
It gives them the ability to. You don't need to know exactly all the critical elements of a machine. You've modeled it out because these operators, they're not only using this machine,
right?
They're using many machines, right? So going there and giving them all the knowledge to make sure you extract all the best out of every machine is beneficial to you.
So Billy, how long did it take from, let's assume that data collection was in place, from that point onwards to put these analytics into use?
So the Odin models, they require at least 6 months worth of data. So 6 months worth of labeled data is what they call it. Like, so you have all these parameters here on the right side and the left side, and the left and the right, the outputs as well. So the outputs are offline measures. So you need some way to like a web interface to enter it in and capture it. And once you have that, they can correlate the outputs to the inputs and develop a model and train it. And once they have that model, they are very good at certain equipments. So within this use case, once you have the data, within a week or so, they'll have the model deployed, and then it's just customization in terms of dashboarding.
In other words, so if you have 6 months worth of data at this point, it takes about a week to implement the model and
train it and employ it and then use it, try it out.
All right, I think can move on to the next.
Next one.
Yep. So based on all the use cases we've heard so far, we want to do another poll. We want to ask this group if you think, based on what you've heard so far, is implementing manufacturing intelligence expensive? So yeah, let's put the poll out there and see what our group thinks. The answer is it's fiction. The majority of our group thinks it is going to be expensive, but that is not the case, and we're going to talk about why that is. The fact is that in this day and age, cloud-based solutions and really affordable hardware has made implementation of manufacturing intelligence very cost-effective for businesses of all sizes. And Pradeep, let's figure out the next slide, Jackie. Pradeep, you want to talk about what enables cloud-based services?
Yeah. So if you look at this one, I think you already know that it tells you that 55% of your survey, everybody thinks it's almost baked in. Like if you think intuitively it's going to be expensive,
right?
But depending on the use cases, it's only at the lowest end, it's only like $1,500 or $1,200.
Yeah.
And the reason is because we leverage a lot of the cloud-based solutions on services like this. And Jackie, if you go to the next slide, we'll show you why. So if you look at this slide, if you look at the rightmost, you see that a lot of the costs, if you try to do this on your own on-prem, a lot of these costs are hidden. So you need to account for IT support. You need labor resources, people who know data sciences, data engineering. You need to take care of disaster recovery. What happens now you've given the operator this Iron Man suit and it doesn't work.
Right.
You're going to be in trouble, right? So uptime is important, disaster recovery is important, maintenance, how do you keep up with scalability? So all of this adds on, and we feel that, or we've always done this when we know for a fact that the total cost of ownership is actually lower when you go to the cloud-based solutions. And the reason is that you don't have to worry about IT support. You don't have to worry about data management costs. Your uptime is always very high. They ensure that you have 99.99% availability. The cybersecurity posture is also very strong when it comes to the cloud, because they are better gatekeepers. Than they'll have to make sure that they've got best in class technologies there, and you can scale very, very quickly. Adding another asset or 3 or 4 assets is mostly allocation of resources, which is configurations for them.
So in other words, using cloud-based solutions really make implementation of manufacturing intelligence very
efficient and cost effective.
Go to the next slide, Jackie. Which leads us to our next poll. And again, we've discussed a lot about implementing manufacturing, and we've talked about some use cases. Now we want to ask, do you believe that manufacturing intelligence projects are complex? And that would mean that only large organizations with the resources and technology to implement it can deploy them. We want to see what our group here thinks. We've luckily I think our group agrees that it is fiction. So and it is true. So while data collection is a crucial component of manufacturing intelligence, it's not the end goal, right? So the end goal is taking that data and implementing data analytics. That's where manufacturing intelligence comes into play. So in terms of resources, if you go to the next slide, the concern that we've heard is, do we have the resources to perform complex data analytics? And what Pradeep's going to talk about is that's not the case. So for every manufacturing site, the data collection is the responsibility of the SMEs, and then the analytics is all pushed off
to the SaaS-based providers. For example, we've always encountered this. Like, I don't have my core competency is with electrical engineering, or we have the manufacturing or the mechanical guys. But we don't do anything with data sciences. How much do we need to know? And the answer is not much, because all we have to, from the plant perspective, you have to worry about your data sets and just the aggregation. The edge node is usually on the plant level. So make sure that we can aggregate all this information and then push it to the cloud. And a lot of the heavy lifting in terms of data sciences is done on the cloud platforms. So they take care of the ingestion rates, the throughputs. They can handle, if it's MQTT or anything else, they can handle thousands of files per second. They do the cleaning of the data. It's called an ETL, extract, transform, load operations. They can do feature engineering based on models. They actually take your data sets, depending on the problem you want to solve. They figure out which model to use, ML model to use, then they'll train it and then deploy it. When they deploy and train it, that's when your domain expertise on the process itself comes into play. So that's where you contribute, at least in this whole journey, in terms of your aggregation and your domain expertise in the model itself. Once it predicts the values, you want to make sure that it's applicable to your plant. And then the dashboarding part of it. And so that's where the segregation of duties are, or if you talk about a RACI, the responsibilities of your vendors are. So you don't need to, and the bottom line is, you don't need to be very savvy in everything of data analytics.
When it comes to data science, something like this. So the bottom line is, the SMEs at the plant site focus on what they know best, provide the data sets, and then the SaaS data platform will take it over from there. So it is not only for large organizations. It is something every business can invest in.
Yes.
We can go to the next slide, Jackie. So that leads us to the question of, how do you start a manufacturing intelligence initiative? The first thing is, Pradeep, wouldn't you say we identify an opportunity, whether it's alarm analytics or anything as simple as alarm analytics or nuisance alarms, and then work from there.
Yeah.
Jump into that.
So I think the most important thing, at least 60% of your problems are identification of a problem, or you first identify a problem so that you can narrow down what you're going to focus on, and then make sure that the problem is measurable. So you baseline it. So today, if you think you have alarms from different sources, and it takes you, if you have a problem in sight, it takes you, say, 4 hours to get the whole information through and get an idea of what's happening. If we implement this problem, can you do this in 1 hour? Right? So baseline it and measure it. Come up with some kind of a measurement or some kind of a performance indicator that it's working for you. In terms of process automation, process optimization is already there. The cost will come through. But in terms of like data platforms, how easy a job is going to be after we implement this, right? And then the opportunity costs of, with that time, you can do something else, capital projects and things like that. So that's where we would go. We would first identify a problem. We'll make sure we have goals which are measurable and time bound. We want to make sure you can achieve time to value is the best things here, right? With SaaS-based initiatives. So want to make sure it is time bound, and then we want to make sure that you have a baseline of what you are now, and then you can measure against this when you have the system in place.
Yeah. If you go to the next slide, Jackie, and at this point, we're going to talk about how can we help. eTech provides a lot of services in terms of how we can help you get started and walk through this process of implementing initiatives. But you want to talk about
so typically, if your company has a problem in mind or a problem set in mind, then you can come to us directly, and we would then have the right fit solution and do the whole road mapping. But in cases where some of our customers, I'm not sure what is there, how do they benchmark themselves against what other people are doing. So we have these assessment activities. So we go and talk through. We have stakeholder meetings with workshops with different groups. We identify all your data resource, your sources, infrastructure that's capable, and then we identify a problem that we can solve together. And then the next step would be recommendations of course of actions.
Yeah. So bottom line is we are here to help with any initiative that you want to think of or that you would like to plan for. We are here to help you plan on those and provide the recommendations and help move forward. Again, this is a quick roadmap of how we implement MI initiatives, and it's basically engaging the stakeholder, assessing the data that currently exists, assessing the infrastructure, and then we provide the recommendations on how to move forward. Our goal again is to be and partner with you along this as you traverse this path and provide the best services that we can. We can go to the next slide, Jackie. And finally, we want, our goal here is that you walk away with some key things. The key takeaways for us here is MI, or manufacturing intelligence, is accessible to businesses of all sizes. And the value that MI brings is in the analysis and the use of the data that you currently have or we need to bring in to improve the operations of the site. Thirdly, implementing manufacturing intelligence, it can be done in a truly cost-effective manner, as we've talked about. And then finally, and this is a key takeaway, is that manufacturing intelligence really is not designed to replace human beings. It's really to augment their capabilities and to help them perform better on a daily basis.
Yep.
Anything else you want to add to that, Pradeep?
No, this is what we wanted to, this is the whole idea of the webinar. So it boils down to these four points.
If you go to the next slide, Jackie, you have questions?
Yeah, so we have a little bit of time for questions. So Vivek and Pradeep, thank you for giving the presentation. That was super informative. We did have a couple questions come through, so I'm going to ask the first one. Can manufacturing intelligence projects be deployed both in the cloud and on premises?
The short answer is yes.
Yeah.
Pradeep, you wanna-
Yeah. Depending on use cases, depending on regulations, then I know some people don't want, or some industries you don't want to have it in the public cloud. We can deploy it on-prem as well.
And I have one more question that came in, which is there low-hanging fruit that you think would serve as a good proof of concept or starting point that might be applicable to a wide range of environments?
Yeah, as we had talked about, you could start with something as simple as getting rid of nuisance alarms.
Or data platforms. So
using
if
the
you
data.
have if you have different disparate sources of data, and you have to look at different systems, data platform will help with that. Primarily for alarming. So if you have a problem with a lot of alarms in different systems, and you have to go to each system to go and identify all of these alarms, the very good use case would be to pipe all of these alarms into one place,
Right.
and then do analytics on them to tell you which one is more fleeting, which one is the most common, which one you want to take care of first, and how you're trending week after week.
Right.
Hopefully it gets improving down as you keep going, and as you identify alarms, you rationalize them and kind of eliminate them if you don't need to.
Right.
It's a nuisance alarm,
and implementing a model that talks, that can differentiate between nuisance alarms and alarms that you don't need to pay attention to. So that would be a good, as an example of a low-hanging fruit, in our opinion.
Data platforms are pretty good.
Awesome. Well, I don't have any other questions right now. So I just want to thank everyone for joining us again, and thank you to Vivek and Pradeep. And we hope you guys enjoyed the webinar. Thank you.
All right. Thank you, everyone.